My screen is visible, beta Dhanunjay?
Yes, ma'am.
Okay. Now in yesterday's class, beta, we have learned what are domain, what are codomain, and what are range. Right? So
Yeah.
will you please tell me what is your range here? What is your domain here?
Domains are like the x-axis of the relation.
See, I have told you that domain is, what is domain? Values of x, beta, right?
Values of x-axis in the relation.
Right. Or you can say domain of R. Domain of R is equal to x such that x belongs to A, where xy belongs to A, for some y belongs to B. This thing I have told you yesterday. Have
Yes,
you
ma'am.
remembered?
Yes,
Okay. So here see, let A is equal to 1, 2, 3, 4, 5 and R be the relation such that R is equal to x comma y such that y is equal to x plus 1. So here values of A set is given 1, 2, 3, 4, 5. So how will you find the relation, beta? How you will find?
A into
Any guess?
A we should do it.
Tell me.
Ma'am, we should do A into A first.
See, in this question, you have given the domain will be, what will be the domain? That you are putting the values of A, B, C. You are putting the values from this set A. Yes, see. Set A has a value 1, 2, 3, 4, 5, right? So when you are putting, put x is equal to 1. Then value of y is 1 plus 1, 2, beta. So your relation will be 1 comma 2. Am I correct? When you are putting 2, then your relation will be 2 comma 3. When you are putting 3, 3 comma 4, then 4 comma 5 and 5 comma 6 we can't write, right? So what are the domain here? Domain are the basic values of x. In this question we have given. So ordered pair is always in the form of x comma y, right?
Yes, ma'am.
Ordered pair. So domain is 1, 2, 3, 4, 5. Am I clear? Is it clear, beta? Dhanunjay, tell me, beta. Is
Ma'am, in
this clear?
relation, ma'am, in
Yeah.
relation, we should add 5 comma 6 also, right? Ma'am?
Yes. And then range will be?
2, 3, 4, 5.
Yes. Will values of y only. So range is 2, comma 3, comma 4, comma 5. You can write. And what is your domain? Codomain, sorry. What is your codomain?
1, 2, 3, 4, 5.
Yesterday I have told you now what is your codomain? Is basically a set with set B, right? So here codomain is this set only 1, 2, 3, 4, 5. Understood, Dhanunjay? Dhanunjay,
Ma'am,
any doubt, beta?
ma'am, can you hear me?
Yes.
Yeah, ma'am, clear.
See, beta, basically codomain of any relation is the set to which relation is defined. So we have defined this relation on this set only, na, A set. So if you are taking a value of x as 1, then your value of y will be 2. If you are taking value of 2, x as 2, then value of y is 3 then. So your codomain is basically this set. Clear? Understood, beta? Speak loudly, Dhanunjay.
Yes, ma'am.
Okay. Now, see, Dhanunjay, if you have to find the number of relations, how many relations are possible? So what you will do, see how you will solve it. See, so first of all, number of relations. Suppose in A set, there are element M, and in B set, there are how many element K, and we have to find number of relations from set A to B, right? So what will be the number of, first of all, you will find A to B. So in relation A to B will be how many element? So it will be Na into Nb. Number of elements into number of elements of B. So it will be M comma K, Mk. Clear, Dhanunjay?
Yes, ma'am.
So now Na, right? The number of subsets in set A will be, how many subsets of this set A will be? 2 raised to the power M or not?
Yes, ma'am. 2 raised to power.
2 raised to the power M. And number of subsets in B element, it will be 2 raised to the power K. Right?
Yes, ma'am.
So number of relations, the number of relations will be equal to 2 raised to the power Mk. Got it my point? Now see, in this question, if set A has 2 elements, so Na is equal to 2 elements, and set B has 4 elements. So relation has how many elements? Their relation 2 comma 4, 8 beta, right? So
Yes, ma'am.
number of relations will be
2 power
2
8.
raised to the power 8. Clear? 2
Yes,
raised
ma'am.
to the power 8. So 2 raised to the power 8 is equal to how much? 256?
Yes, ma'am.
Yes, Dhanunjay. 256 will be the answer. Got it?
Got it, ma'am.
Okay. Kindly note it down it. Please note this, Vita.
I'm noted.
Noted? Okay. Now next is, see, in question number 3, you have given See, set A is equal to 1, 4, 8, 9. Set A has element 1, 4, 8, 9. And set B is my 1, 2, minus 1, minus 2, minus 3, 3, 5. And R is the relation from a set A to set B such that x, y is equal to y square. Then you have to find the codomain of the set. Then you have to find the domain of the set. So, how we will solve it, beta? So, first of all, what will be your domain? Tell me.
Ma'am, 4 and 9?
4 and
9.
see, beta, first. See. A set is equal to 1, 4, 8, 9 and B set is this and R is a relation. So we know that in a previous question also I have told you that we know that domain of a relation is the set from which is the set from which relation is defined. So your relation is defined from this set now 1, 4, 8, 9. Right? You can check x is equal to y square. X is equal to, this is y square. X is equal to y square. Right?
Yes, ma'am.
So your domain is 1, 4, 8, 9. And Dhanunjay, what will be your range, beta? Please tell me
Ma'am,
what will be your range.
1, 2, minus 1, minus 2, minus 3, 3, 5.
Yes, your range will be 1 minus 1. Good. Your range will be 1 minus 1, minus 2, 2, minus 3 and 3. And then your codomain, beta.
Ma'am, it will
What
also
will
be.
be? Yes, because we know that the codomain of a relation is the set. Now codomain is 1 minus 1, minus 2, 2, minus 3, 3. And your relation. What will be your relation, beta? If you are taking 1, then square of 1 is 1 only. Then if you are taking minus 1, square of minus 1 is 1 only. Then if you are taking 2, square of 2 is 4 only. If you are taking minus 2, square of this is 4 only. And if you are taking 3, then it will be 9, 3. And if you are taking minus 3, 9, minus 3. Right? Clear, beta? Dhanunjay?
Yes.
Clear? So your range will be, so we know that codomain of, of codomain of a relation codomain of a relation is the set to which relation is defined. Got it my point, beta? Dhananjay? Understood?
Yes, ma'am, understood.
Please note it down it.
Yes.
Ma'am.
Done?
Yes, ma'am.
Okay. Now next is after this function, this relation, function term comes. So what do you mean by function? Functions, a function is a relation between a set of inputs and a set of permissible outputs with a property that each input is related to exactly one output. Okay. So see, suppose beta, or a function, you can thought like a mechanism. Suppose there is a mechanism, or you can say device. Suppose this is a mechanism, or you can say any device. Okay. And you are giving any input, right? And after processing, it will give you output. Just like your computer, if you are feeding something in your computer, or if you are doing calculation in your calculator, you are feeding the values only, na? Right, beta? And after this calculation, after this whole process, you will get the output, single one output, right? So In terms of maths, this is called a function. See, in the definition also it is written, a function is a relation between the set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. So let A and B be two and non-empty sets mapping from A to B will be a function only when every element in set A has one end and one image. So what do you mean by this? See. Suppose through ray diagram, suppose this is your set A and this is your set B, right? Here elements are 1, 2, 3, 4 and here elements are A, B, C, D. So this set A has image in B, right? So this is your input and this is your output. You can say these are the values of X you are putting and these are the values of Y. After putting the values of X, you will get after putting values of X. Got it my point, beta? Dhanunjay?
Yes, ma'am.
Understood?
Yes, ma'am.
Can you tell me what do you mean by function? Tell me, beta.
Uh, then I'll give you.
Just tell me what do you mean by function, beta. In simple statement, in simple language, you can tell. See, if function you can thought as a mechanism or you can say device which gives a unique output to every input. Clear? Clear, beta? Because if you are giving any inputs, you will get only the single output. Clear, Dhanunjay? Dhanunjay, you are not audible, beta. Jaswant,
Yes, ma'am.
today you have joined late, beta.
Ma'am, no, ma'am. I was there before. Ma'am, I joined at 5, uh, 5:30 lakh, 5:35 lakh.
And have you understood this topic, functions, beta? Jaswant?
Ma'am, yes.
Okay. Dhanunjay have also understood. Now see representation of functions. How will you represent the function? The functions are generally represented as fx. It means it is a function of x. It means the values of the function is in terms of x. See here x is equal to x cube, not it is x3, it is x cube. So it is said that f of x is equal to x cube. Okay. Or function can be represented by, if some other function is given, suppose in 10th class you have studied a quadratic polynomial. Have you studied this? Quadratic polynomial? And if you are representing any quadratic polynomial, suppose polynomial is given in terms of u. So you will represent that this is the polynomial of function u. Right? So here g, suppose a polynomial, suppose a function is given in terms of t, so you will write gt. Suppose a function is given in terms of z, so you will write gz. Got it, beta? Understood? Dhanunjay, Jaswant, understood, beta? Now, image of an element. Image of an element. So, unique element, suppose a unique element y belongs to set y is called the image. Is called the image of element x belongs to x under the mapping. Mapping means f is a function such that x tends to y. A to b, x function set A to set B, or you can say set x to set y, and it is denoted by y is equal to fx. Okay. And the element y is also called the value of function. Value of y is also called value of the function f at x. Okay. So value of y is also called value of the function f at x. Understood, Dhanunjay?
Mom, could you explain it again?
Yes, beta, I will explain it. See, what do you mean by the image? Image basically, see, this is your set A. Mapping is this, set A and set B, right? Here elements are 1, 2, 3. Here elements are x, y, z. See, x belongs to y. Suppose a mapping is there that set A to set B. So, ax this. So, here image of 1 will be x, image of 2 will be y, and image of 3 will be z. Got it, my point?
Yes, mom, I got.
Okay. So, this is the thing. Now with the help of Venn diagram also, so now types of functions. Type of functions. So 1-1 function. What do you mean by this 1-1 function? If each element in the domain of a function has a distinct means different, has a different image in the codomain, the function is said to be 1-1. Okay. So see. Suppose this is your set A. This is your set B. So here elements are 1, 2, 3, 4. Here A, B, C, D. So see beta, the image of 1 is A, image of 2 is B, image of 3 is D, image of 4 is C. So here each element of A, right, having image, distinct image in set B. Got it my point? See, one image is A. So no element have two images, or you can say no two elements have the same image. Clear? Suppose if you have given this set, suppose this is your set A and this is your set B. 1, 2, 3, 4, and this is your A, B, C, D. And suppose if one has this A image and this B image, 2 has C image and D image. So here elements of one element of A has two images. So this is not 1-1. Understood, beta?